Now see the first question of transmission of heat. Question number 1 is this. There are 6 identical conducting rods are joined. The point A and D are maintained at temperature 200 Celsius and 20 degrees Celsius respectively. Then find the temperature of the junction B will be first option 120 degrees Celsius, second option 100 degrees Celsius, third option 140 degrees Celsius, and fourth option 80 degrees Celsius. There are 6 rods and all are identical like this. 1 rod, 2 rod, 3 rods, then these are the 4, 5, then 6. A, B, C and D. Here temperature is 200 degrees Celsius. Here temperature is 20 degrees Celsius. This is the temperature B which they are asking. So it is equivalent to your electrical circuit like this. 1 this resistance. Likewise. So since all are the identical, all having same resistance R, R and R. So here heat current H, here your H1, H2, then H. And this temperature given 200. So this temperature your T. So see here, heat current H. H is your 200 minus T by R. This is equal to this temperature your 20. Direct we can say from here to here also. See, this R and R in series, the 2R, this also 2R, and 2R, 2R in parallel become R. So R plus R plus R in series. So 200 minus 20 by total resistance your 3R. So now we can simplify here. 600 minus 3T is equal to your 180. So 3T is your 420. So T is your 140 degrees Celsius. The temperature of the junction B is 140 degrees Celsius. The correct option, your answer number 3 is the correct option. The question number 2. 5 rods of the same dimension are arranged as shown. Their thermally conductivities are K1, K2, K3, K4, K5. When points A and B are maintained at different temperatures, no heat flows through the central rod. It follows that first option K1 is equal to K4 and K2 is equal to K3. Second option K1 by K4 is equal to K2 by K3. Third option K1 K4 is equal to K2 K3. And the fourth option K1 K2 is equal to K3 K4. As it is given, there are 5 rods. 1 rod, 2 rod, 3, 4 and 5th. These are the different points. What they are giving, their dimensions are same, but their thermal conductivity are different. This is your K1, this is K2, this is K3, this is K4 and this is K5. Since and as we can say, it is just like equivalent to electrical circuit here, and we know कि when there is a no current here, no current means these and this. From here we will get R1 into R4 is equal to R2 into R3. R is the thermal resistance. R thermal is equal to your L by Ka. L and A are their dimension. K is the thermal conductivity. All having same dimension. So R1, resistance of this, that have thermal conductivity K1. L by K1A, this is your L by K4A, this is your L by K2A, and this is your L by K3A. From this we can have K1 K4 is equal to K2 K3. The K1 K4 is equal to K2 K3. So our correct option, your option number 3. This is the correct answer. Question number 3. It is given as a conical metallic body is heated at the middle if the body was viewed from its ends. Then the first option, there will be no effect on the body. Second option, body will contract from middle. Third option, no strain is produced in the body. Fourth option, maximum compressive stress will be on the sides of a body towards the right side. As per the diagram, if we are looking, this is your conical body, and this body is fixed about 2 line. Now it has been given heat from the middle. This is your right side, this is your left side. So what will happen? Due to the heat, it will try to expand. When it will try to expand, so wall will apply force from that side. So stress is equal to your force per unit area. Since the area of this side is less, so stress at the left side will be less, and area of the right side is more, so stress of the right side will be more. So maximum compressive stress from the right side. So correct option, your option number 4. So this is the correct answer. Question number 4. The rate of emission of heat from a black body at 0 degrees Celsius is R. Its rate of emission at 273 degrees Celsius is. First option, your 4R. Second option, your 8R. Third option, your 16R. Fourth option, your 32R. So as we know, as per the Stephen's law, rate of heat emission from black body is directly proportional to 4th power of absolute temperature. So E1 by E2 can be said as T1 by T2 to the power 4. So E1 means initially rate of heat is given here R, that we want E2, initial temperature 0 degree Celsius, so 273 Kelvin, and then T2 given 273 degrees Celsius, so 273 plus 273, so 2 into 273 whole to the power 4. So this is your 1 by 16. So E2 is equal to your 16R. So correct option, your option number 3. Question number 5. The radiant energy received on the earth from the sun has a flux of 1.4 kilowatt per meter square away from the sun. Should the temperature of the sun rises by a factor √2 and its radius contract by the same factor, the energy flux at the earth location would be, other thing remaining unchanged. First option 0.7 kilowatt per meter square. Second option 1.4 kilowatt per meter square. Third option 2.8 kilowatt per meter square, and the fourth option 1.4 kilowatt per meter square. Intensity is your energy falling or power per unit area. And power is coming from the earth's surface, that is your E sigma area of the sun, 4 pi r is the radius of sun, square t to the power 4 by area. How much distance is coming? 4 pi r square. This is the intensity, and this intensity means E emissivity, sigma is difference constant, R is radius of sun, temperature of sun, small r is the distance of earth from the sun. Only they are changing the radius as well as temperature of sun. So intensity is proportional to, we can say, Rs square T to the power 4. So I1 by I2 is equal to your Rs 1 by Rs2 square T1 by T2 to the power 4. Initial intensity given 1.4. Now they are asking I2. What they are saying? Radius. Radius contract by the root 2 times and temperature rises by root 2 times. So initial radius your R. Now radius contract. It means R by root 2. But temperature, let initial T, temperature increases root 2 of 4. So this will come your 1 by 2. So I2 is equal to 2.8 kilowatt per meter square. So this is the correct option. So option number 3 is the answer. Question number 6. A body cools from 85 degrees Celsius to 80 degrees Celsius in 10 minutes when the surroundings are at a temperature 42.5 degrees Celsius. The time taken by the body to register a 5 degree fall in temperature when the average temperature of the body is 48 degrees Celsius above its surrounding is. First is your 8.3 minute, second 10 minute, third is 12 minute, and fourth is 18 minute. Now see, according to Newton's law of cooling, d theta by dt is your minus k theta minus theta naught. So initially they are saying body cools from 85 to 80. 85 to 80 means 5 degree. In the time they are saying here 10 minute by 10 minus k theta value your 85 to 80, that is the difference is your average value your 42.5 minus theta naught is given here, temperature of the surrounding, that is your 82.5. This is the initial condition. So 1 by 2 is your minus 40k. This is your first equation. In the second they are saying find the time taken by the body to register a 5 degree fall in temperature when the average temperature of the body is 48 degrees Celsius above its surrounding. So now in the second case, 5 degree fall in temperature, 5 in time t, and the value of k. Now theta minus theta naught. When the temperature, average temperature of the body is 48 degrees Celsius above, so this minus this your 48 degree. So now we can put the value of minus k. Minus k is your 1 by 40, 1 by 80 into 48. So t will be here 5 into 80 by 48, 8, 10, 8, 6, 50 by 6. So t is your 8.2 minute around. So 8.2 minute is the correct option. So option number 1 is the correct answer. Question number 7. A room has two walls of thickness 10 cm and 20 cm respectively. the thermal conductivity of the material of the first wall is K, while that of the material of the second is 2K. If the temperature of the room is 20 degrees Celsius and the outer temperature is your 38 degrees Celsius, the temperature of the junction of the wall is in a steady state. The first option 29 degrees Celsius, second option 32 degrees Celsius, third option 26 degrees Celsius, and the fourth option 36 degrees Celsius. So as per the given condition here, these are the two walls. These are the two walls. This is your room and this is your surrounding. This is your surrounding space, and temperature inside the room is 20 degrees Celsius, while surrounding temperature your 38 degrees Celsius, room temperature 20 degrees Celsius, and thickness of the first wall is 10 and the second wall is 20. This is your 10, this is your 20, and they are asking the temperature of this theta. So whatever heat will flow from there, same heat will go from this. Thermal conductivity is given K and 2K. The rate of flow of heat K in 2K, area is same, 38 minus theta by distance your 20 is equal to K A theta minus 20 by thickness your 10. Then we will get the value of theta. So this is 2, 10, 10 cancel, Ka, K cancel. That gives us 38 minus theta is your theta minus 20. So 2 theta is 58. That gives us theta is 29 degrees Celsius. So correct option is your option number 1. Question number 8. This is based on statement 1 and 2. Statement 1 is given: the sun radiates towards the earth, but the earth does not radiate in the direction of sun. The second statement is given: the sun is at a higher temperature than the earth. So as per the question here, so temperature statement, first option statement 1 is true, while statement 2 is true. Statement 2 is the correct explanation of statement 1. Second option given, statement 1 is true, statement 2 is true, but the statement 2 is not the correct explanation of statement 1. Third option, statement 1 is false and statement 2 is true, and the fourth option, statement 1 is true and statement 2 is false. The first thing is that all the body are radiating heat, as sun is also radiating heat from sun to earth. Similarly, earth is also radiating heat in all the direction. So statement 1 is the false statement. While since the temperature of earth's surface is less than the temperature of your sun, so we can say the sun is at higher temperature than the earth. So statement 2 is the correct. The statement 2 is true, while statement 1 is false. So our correct option, your option number 3 is the correct option. Now see the question number 9. For a composite bar, one after the other, which of these graphs is possible given that K1 is not equal to K2, where K1 and K2 are the thermal conductivity of the material of which the bar are made from it. In the first option, the graph is given between theta versus x. So here we can say like this. let this be your composite bar having their thermal conductivity K1 and K2. Let this be at higher temperature theta 1 and theta 2. So one thing is that if we are talking about the temperature gradient, so temperature gradient, because our graph is between temperature variation in the rod versus distance x. So temperature gradient d theta by dx, whatever heat is coming from here, H is equal to your Ka d theta by dx. And same thing we can get here, but the difference is that as K value will be different. As K value will be different, so d theta by dt will be your straight line and that have constant slope. So if we are plotting a graph between variation of temperature theta with x, first from here to here, this type of slope may come, and when this reaches here, then the slope will be your, either it can go like this direction or it can go like this, depending on which one is your thermal conductivity more or less, that depends. So more appropriate curve is the curve, second is the most accurate graph. So answer is your 2 is the most appropriate option. Question number 10. 3 identical rods made of same materials are connected as shown in figure. The ice which is in contact with the free end of the rod number 3 melts at the rate of 3 gram per second. Then the heat current in the first rod is. The latent heat of ice given 80 calorie per gram. The first option is your 40 watt. Second option 240 watt. Third option 320 watt. Fourth option 320 calorie per gram. Now it is given like this. Okay, now see, as per the given information, we are having 3 rods, one rod like this, another this, and third rod is this. This is your rod number 1, 2, this is 3. Temperature of this junction is given 40, this is 60, this is given 40 degree, and here ice is there. Ice is there at 0 degrees Celsius. And this temperature is not given theta. Here we have to find the rate of flow of heat. All are the identical rods. So it is given 3 gram ice melt per second. So we can calculate how much heat is coming here. Heat is coming at 3 gram, 3 into 80 calorie per second. So 240 calorie per second heat is coming here. So that is H1 we can say. Here we can say your H2. H is this. So H is equal to H1 plus H2. So H1, see, H1 can be also said as temperature difference by thermal resistance R. R is equal to 60 by H is 240. So this is your 1 by 4. Here also R is 1 by 4. So H2. H2 is equal to temperature difference your 20 by R thermal 1 by 4. So this is your 80. So H1 is your 240. H2 your 80. So H will be 320 calorie per second. This is the rate of flow of heat. So correct option your option number 4. Question number 11. Assertion and region based question here. So assertion is that thermal radiation emitted by a body is proportional to T to the power x, where T is the absolute temperature and the value of x is your 4 is for all bodies. And now region R. The value of x is less than 4 for colored bodies except black. So options are first both A and R are correct and R explain A. Second, both A and R are correct and R does not explain A. Third is your A is your correct, R is wrong. Fourth is your A is wrong and R is correct. So as per the Stephen's law of thermal radiation, rate of radiation or E, rate of radiation or E is given as E sigma A T to the power 4. It is applicable for all type of bodies. It is applicable for all types of bodies. Only as the body changes, so your emissivity will change. For black body, emissivity will be 1, and for other body, depending on the nature of surface, the emissivity will change. But the rate of radiation is directly proportional to T to the power 4, and where X is equal to 4. So here our option number 1 or assertion is the correct, but reason is a false, wrong. So option number 3 is the correct answer. So answer is your third is the correct answer. Question number 12. The initial temperature of metallic sphere and disk of same radius and same nature are same. The rate of their cooling. First option your 1:4. Second option 4:2:1. Third option 1:2, and the fourth option 2:1. Rate of cooling. As per the Stephen's law, rate of radiation or rate of cooling is directly proportional to surface area and directly proportional to T to the power 4. In case of these here sphere and disk, since the temperature of both are your same, temperature of both same, but sphere, surface area of a sphere is 4 pi r square, and the surface area of disk, one side disk have area pi r square and back side area is 2 pi r square. The total area your pi r square plus pi r square, 2 pi r square. So for a sphere, the rate of cooling for a sphere versus disk is equal to your 2 by 1, because this is 4 pi square, this is 2 pi square, so 2:1, so 2:1. So correct option is the option number 4 is the correct answer. Question number 13. A body takes 10 minutes to cool from 60 to 59 degrees Celsius. If the temperature of surrounding is 25 degrees Celsius, then temperature of the body after next 10 minutes will be. First option 48 degrees Celsius, second option 46 degrees Celsius, third option 42.85 degrees Celsius, and the fourth option 49 degrees Celsius. See, according to Newton's law of cooling, d theta by dt or minus k theta minus theta naught. For the given information 60 to 59 in a difference temperature of 1, it takes 10 minutes. It takes 10 minutes, and minus k theta is the average of these two. 60 plus 59 by 2 to 59.5 minus surrounding temperature your 25. So this will be your minus Now we can subtract here. So this is your 34.5 K. Now this is your first condition we can say. Similarly, in the second it is given here, temperature has to be decreased. How much temperature will decrease in next 10 minutes? So d theta that we have to find. So 59 is the right now temperature. The final temperature your theta in time your 10. That is equal to your minus K theta 59 plus theta by 2 minus theta naught 25. This is your equation number 2. We can divide from equation 1 and 2. Divide this 1 by 59 point theta, that is equal to your 34.5 by this we can simplify. This is 50, 59 minus 59, 9 plus theta into 2. So this is your 69 by 9 plus theta. Now we can simplify this. After simplifying, theta value will come that your 42.85 degrees Celsius. So our correct option is your option number 3. Question number 14. The temperature of two stars are in the ratio 3:2. If the wavelength of maximum radiation from first body is 4000 angstrom, what is the corresponding wavelength of the second body? First option 9000 angstrom, second option 6000 angstrom, third option 2000 angstrom, and fourth option 8000 angstrom. See, as per the Wales displacement method or Wales displacement law, Wales displacement law, lambda maximum into T is your constant. So lambda maximum is the wavelength corresponding to maximum number of radiations. T is the temperature. So lambda maximum for 1 T1, that is equal to lambda maximum for 2 into T2. The lambda maximum for 1, it is given here 4000 angstrom into T1 by T2 ratio given 3/2. 3/2. The lambda maximum for second body is, we can get from here, lambda maximum for second body is 6000 angstrom. So this is the answer. So correct option is your option number 2. Question number 15. An object is cooled from 75 degrees Celsius to 65 degrees Celsius in 2 minutes in a room at 30 degrees Celsius. The time taken to cool the same object from 55 degrees Celsius to 45 degrees Celsius in the same room is, first option 5 minutes, second option 3 minutes, third option 4 minutes, and the fourth option 2 minutes. Now see, according to Newton's law of cooling, d theta by dt or minus k theta minus theta naught. First case. In the first case they are saying change in temperature is 75 to 65 in, that is 2 minutes. 75 minus 65 in 2 minutes. This is the first condition given. And so here minus k theta is your 75 plus 65 by 2. Theta naught given room temperature is your 30 degrees Celsius. So this is your 5 minus k is 70, 70 minus 30 or 40 into 40. This is let your first condition. In second case when the temperature changes from 55 to 45. Second case 55 to 45, in time t we have to find minus k, 55 plus 45 by 2 minus 30. So this is your 10 by t minus k, this is your 50 minus 30, 20. So now we can substitute the value here. So from first and second, from first minus k is your 1 by 8. From first and second, 10 by t is equal to minus k is your 1 by 8, 1 by 8 into 20. So that gives us t is equal to your 4 minute. T is 4 minutes. So correct option is your option number 3. Question number 16. A cylindrical rod with one end is in a steam chamber and the other end in the ice result in a melting of 0.1 gram of ice per second. If the rod is replaced by another with half the length and double the radius of the first, and if the thermal conductivity of material of the second rod is 1 by 4 that of first, then the rate at which ice melt will be. First option 3.2 gram per second, second option 1.6 gram per second, third option 0.2 gram per second, and the fourth option 0.1 gram per second. Here there are two situations are given. Now see the first situation and this is your second. This is your rod, length your let L, one end at 0 degree and another end as your 100 degrees Celsius. And from here it is given 0.1 gram ice melt per second. Thermal conductivity of this let your K, area is your A. The first thing, rate of heat flow. Q is equal to Ka 100 by L. This is your dm by dt into L. L into dm by dt. So this we can say 100 Ka by L, L latent heat, dm by dt, that is given here 0.1 gram. 0.1. Now in second case here, rod length here L by 2, temperature here same difference, 100 and 0 degree, temperature difference is same, but length of the rod is your 1 by 2 and the double the radius of the first. Radius of this your double. If radius is double, area become your 4 times, because area is your pi r square. The radius double, so area will be your 4 times. As well as thermal conductivity of material of second rod 1 by 4 that of the first. Here thermal conductivity was K, this is your K by 4. Now rate of flow of heat from here, K, A area 4A, Ka delta theta 100 by L, L by 2. So this is your 200 Ka by L. 200 Ka by L and 100 Ka by L is your this. So this is equal to your L dm by dt. We can say here Ka by L. Ka by L is your L, 0.1 by 100 into 200, that your L, dm by dt. L and L cancel, 100 cancel, so dm by dt will be your 0.2 and this is your gram per second. Now the 0.2 gram per second the ice will melt. So correct option, your option number third option is the correct option.